Welcome to this first talk about Linux. Well, the second actually. This time you're actually going to get into it and start hacking away. And yeah, we're going to start shortly with Simon. He's going to be doing this talk today. He's a fellow computer science student and long-time Linux user. And I kindly ask you to get one of these sheets we laid out. It's not an exam, don't worry. And fill it out. It's a questionnaire, and it gives feedback to us. And really, we do evaluate that very carefully to improve these courses. Right. Thanks, everyone.
Oh, thank you. I would like to welcome everybody here. Who here saw me 2 weeks ago on the Linux introduction? Oh, that's quite a few. Who attended the install days? Nice. Who were successful? Well, not so impressive. Maybe we can improve that for next year. Who runs Linux? Everybody. Nice. So, I'm going to introduce you to the Linux command line. Moment, please. Yes. Here. So, what are we going to talk about today? It's going to be about getting to know the command line, a basic introduction, what's what, how to navigate your file system, how to manipulate basic files and folders, managing your software with a package manager, and dealing with storage devices, and yeah, basically getting ready for the next course, for the Power of Linux course. I really recommend that, to have a look at that too. That will be tomorrow. So, why do we do this? For years and years, students have been asking, could you do something more technical? Could you get us into the system a little bit more? The GUI is more or less self-explanatory. The command line can be quite scary. Even I, after 12 years of using Linux, sometimes I don't really feel comfortable using the command line. But it's a very, very sophisticated tool. It gives you access to all the power the machine offers. It's also a very nice way to interact with, for example, your router or your NAS, if you have an SSH or Telnet access to that. It helps you to recover your system in case you broke something. It's usually the last thing alive, or if you have to actually get in there with a live medium, the command line is the only thing that is going to help you. And it's good if you're a little bit fluent in that. And last but not least, the knowledge of the command line is portable between basically any Unix system. So the basics we teach you here, you can also use on a Mac or on an old Unix mainframe, in case any of you still have access to one of those. Then let's jump in right here. What you see here is the command prompt that will face you as soon as you open a terminal emulator. It's basically an overview of where you're at. First, you have your username that you use on the system. Then, as a separator, the @ is used. That's from heritage from old times where you actually logged into systems remotely via a terminal, and then followed by the host name, so you know on what machine you're currently working, followed by the directory where you are at the moment, and lastly the interpreter sign. That's the delimiter of the prompt, and it usually also tells you in what privilege mode you are. Most systems change to a different interpreter sign as soon as you're root, so you don't screw things up. Now, this is another example from Arch Linux. Looks basically the same, a little bit of different characters, but the idea stays the same. It tells you where you are and who you are. So it's a quite nice, let's say, beacon to orient yourself. Of course, there are more user-friendly versions of a terminal emulator. This is Fish. Fish aims at newer users to get you acclimatized with the command line. So then, the next and most important command, change directory. CD is the short version for change directory. It lets you basically jump to an arbitrary position in the file system. In this example, we change to the folder downloads. We are currently in our home directory, and our home directory contains the folder downloads. And to switch to this folder, we type cd downloads, and then our working directory is changed to download. Now, if you want to know where you are at the moment, pwd will tell you where you are. We stepped down one folder from our home folder and are now in downloads, so the absolute path to the folder reads /home/Simon, my username, /downloads. There's also an easy way back. If you type 2 dots, this means parent directory. You can use this in any opportunity where you have to specify a path. 2 dots always tells the computer this is relative to the directory directly above, and if you just type 2 dots as argument for CD, you're taken to the parent directory, and if you run pwd again, you get again your home folder. This is a little bit an advanced example. We now jump into 2 directories down, but this also works with a completely different path in your file system. You can arbitrarily jump around, opposed to a GUI file manager where you usually have to click stage by stage, and if you want to navigate down in a structure that is 10 levels deep, that can be quite cumbersome. Then, of course, the same way back works as well. 2 dots and then a slash and 2 dots again takes you 2 levels up in the structure. If you ever get lost and want to get back to your home directory, a simple cd without arguments will take you back to your home directory. This is all a little bit abstract, and to give you a better idea how this whole thing is structured, we prepared this graph. The slash back here, that's the root. Root means that's the root of the file tree. The file system in Linux is one coherent tree usually, and you get this top level of folders. This will always be there no matter what kind of Linux system you're on, and these are the basic organizational units you will deal with. The root directory at the top, that's the home directory of the root user. Next is the home folder. This is where all the user data is stored. If you remember, on the install days, there you had the opportunity to put this folder onto a separate disk partition. This allows, for example, to tear down the whole system around the user data and build a new one, and you can just get the home folder into the system again, and your user data hasn't changed while you maybe replaced Arch Linux with Fedora. Next up, I want to talk about the dev directory. This is a directory that is not really a directory. It holds information about the devices that are connected to your machine or are available in your machine. We will look at this later in the context of storage devices, but also all kinds of sensors are available there. In this example, we also have a memory card listed. The next important directory is USR. That's where all your programs go, and libraries and other stuff that generally can be installed. The bin directory is somewhat similar, but it holds mainly the bare bones tools that you use from the command line that really are very basic to the system. etc is your configuration directory. Everything that's system configuration goes there. Everything that's a global configuration lives in there. Then what's also useful sometimes is the boot directory, where everything goes that's needed to boot your system. That's just an overview, and if you have this in your head as a navigational aid, this is always very useful. So now, if we can change directories, we also want to know what's inside a directory. And for this, we use the list command, short ls. The ls command just lists what's inside your directory, subdirectories, documents, configuration files, and so on. Yes. Then the ls command works together with the cd command, and we previously talked about arguments, or I mentioned arguments. Arguments are a general concept in the command line. Everything that's not a command is an argument. Arguments are given like here, downloads. This is basically data that's provided to the command, and you jump down into the next directory called downloads. But for other commands, there can be many different arguments. For example, we will later see the cp command for copy. It takes two inputs, copies one file to another location. Then yeah, that's basically an example of this. You can list multiple directories with one list instruction. You get the downloads listing and then the listing of the home directory. Then there are options to commands. These are special kinds of arguments. They are either prefaced with one tag for short options, or with two tags for long options. Long options are usually the little bit more obscure ones that you don't use that often, but options that are used frequently get these abbreviated short options with one tag. In this example, we have ls with the a or all argument, and it basically tells ls to list everything that's inside a directory. And this makes ls list also the hidden files. Hidden files in Linux are demarked by a dot leading the command, the file name. If you don't specify a, you only see meow.txt. If you specify it, you see also the hidden file. Then the L option for ls gives you a long list with more information. It tells you what the permissions on the file are, so who can do what to the file, who is the owner of the file, to which group belongs the file, and when it was last modified, and also how big it is. If you find kilobytes a little bit unwieldy, oh no, bytes. It's in bytes. If you find bytes a little bit unwieldy, you can specify the H option for human readable, and then it tells you the file size in useful megabytes, gigabytes, terabytes, whatever. this is the case with many different listing commands that can adapt your output for normal humans. Then we previously saw that spaces are quite important. They are used to separate different arguments. And of course, if you have a space in a file name, I'd recommend to first of all avoid this. If you're naming files, avoid spaces and generally all umlauts and special characters except tags, underlines, and dots. It will make your life much easier. There will come a point where something doesn't work quite as you intend if you use special characters, but there's a way around, at least around spaces. If you put either a slash in front of the space or surround the whole file name with quotation marks, you can use spaces, but it's not recommended. So what do you do if you have a command and you don't know what it does, or you can't remember anymore what it does or what options it takes? There's always help available with the man command. It's, after ls and cd, the most important command you can find because it allows you to dig deeper into your system. And often, if you ask something about a command, you just get told, have you read the man page? That's not really useful, it's not really kind, but the man page always gives you a wealth of information. You just type man and the command you want to learn more about, and you get an output like this. It gives you a basic description of what the command does, what it is. Then there's a synopsis part. This gives you an idea what options are required in what order. Everything that's in square brackets is optional. So ls takes options and file names, but you don't need to specify it, as we saw. You can just type ls and it will automatically output the contents of the current directory. Then you get a long list of options usually, and at the bottom you get miscellaneous information like author and where to report bugs and so on. Yes, of course, I forgot. Searching in a man page. Man pages can get quite long and are somewhat unwieldy sometimes. But with the slash command, you can search inside your man page. If you want to repeat the search term, you just hit the N key or a big N for a backward search. And closing a man page, just press Q. We saw command line, a lot of typing. And we're humans, we're lazy, especially computer geeks, they are very lazy. And therefore the command line has built in different usability tools that help you to avoid typing, to move faster. And I'm going to bring you some general tips. There are loads more, but these are the most useful ones and those that are easy to pick up. If you were typing something, if it's a command or a file name or something like that, you can hit the tab on your keyboard, and the interpreter will try to suggest you useful completions. So this works like this. If you want to change from your home directory to, say, desktop, you can type cd and then a capital D and press tab, and then it will suggest completions. And if you want to further narrow down your search, you can type a E, and then if you press tab again, you get the completion to documents. If it's not that clear, the next character you type, you just narrow down the search space and you can type until you get the completion that matches what you're actually looking for. Yes, that was what I just talked about. If you want to repeat the command or repeat a similar version of the command you just issued, you can use the arrow up key, and that will just fetch the last instruction that you issued. This works with quite a large buffer, also over multiple sessions. So if you had a session last time and you want to reuse some command, just hit the up key a few times and you'll find your command. Just works like this. Bang, we used CD downloads before, so it appears again. There are also other navigational keys like the home and the end button. You probably never use the home or end button on your keyboard. This is a nice opportunity. Also Ctrl-E or Ctrl-A works the same. If you want to jump between words on your input, you can use the Control and arrow keys to jump word by word. Then the command history is also searchable. After hitting the arrow key up 5-6 times, this gets tiresome. And again, we are lazy people, so you just hit Ctrl-R and type for what you're looking for. Maybe you also only remember a part of the command, a file name maybe that you used, but not the command exactly that you used. And as I said, you hit Ctrl-R and then you type, and it will give you suggestions that match. And then, with the tab or enter, you select this command and it gets fetched into your current input. You can edit again and then issue the command. Another efficiency tool is the double bang. This will just repeat the last command. If you, for example, combine it with sudo, that's the command to run something as a super user, you basically say, last command, oh, that doesn't work like you see here, permissions denied, use sudo double bang, and you suddenly get access to the file. Globs are a very extensive topic. I will only talk about the most used one. That's the wildcard, or also star character. It basically matches anything. If you just type a star, it will take everything that matches inside a directory and type rm star, it will remove everything in this directory. But it can be used more selectively because it's part of your argument and it just matches everything that is in addition to what you just typed. For example, here, if you see this listing of this directory, and you want to work with everything that starts with doku, you can use this globbing character, the wildcard, to remove, as I told you before, all things that start with doku and then whatever is after it. You can also use multiple stars to match different patterns. You can get quite creative with this. There are also other globbing characters, but that would be a little bit too much for this overview. This is the same thing over again. We now have deleted the docu. We want to delete everything that has analysis in the name. Same thing over again. Type the star at the front and at the back, so you get those things that start with an analysis and those things that end with analysis, and gone they are. If you start a process that doesn't abort anymore, if you have a loop that runs forever, or it's doing something you didn't want, and you're like, oh no, don't delete all my family photos, you can save your bacon by very quickly pressing Ctrl+C, that will cancel the currently running task, hopefully. And then editors. Editors, if you want to... Nope. Here, yes, editors. There are quite a lot of editors available for the command line. A very easy one is Nano. It's a really, really simple one. You can just type stuff in, and then you use the keyboard bindings at the bottom here to save your file, copy and paste, and so on. This character here designates a control command. So you typed something in, and then you want to save it. Either use Ctrl+O or Ctrl+X. If you hit Ctrl+X, it will ask you if you want to save it or discard your changes. Yeah, just very basic text editing. There are also very advanced text editors available, for example, Vim or Emacs. I'd really recommend, if you want to work a lot with Linux, it's recommendable to either learn Emacs or Vim. They really, really help you writing, because they are made for people who like physical keyboards, and you won't have to lift your hands from the keyboard for anything. And I personally prefer the keyboard. A lot of people prefer the mouse. I am a keyboard guy. If you just want to look at the file, you don't need it to open it in a text editor and maybe make an unintended change. Less will open for you a file to look at it. It takes a file as an argument. We want, for example, to look at this letter. We type less, and it displays the letter. Maybe you recognize something. Looks very similar to what we saw in the man page at the bottom. Man actually uses less to display the contents of man pages. Thereby you can use all the shortcuts we mentioned before to search and get help with H or Q to close your less session. If you don't want to waste the whole screen, or you just want to look at a very short file, you can use cut. Cut was used for concatenating files historically, but you also can dump whatever is in a file on your screen. I use this a lot to view small configuration files. If you have a large source code, it doesn't really make sense, because all the text scrolls up, and then you see just the last few lines on your terminal. I mentioned the copy command, very basic command. It copies stuff from one location to another. It basically makes a clone of our letter. We can't name it letter again, because that would obviously be a collision, but it makes just a copy. Nothing much to say about this. Then there is move. If you want to move something from one location to the other and delete the old copy, you don't have to do this all manually. You just use the mv command for move. It's also quite handy to rename stuff. If you made a typo, for example, in a file name, you just move it to a new file and it's renamed. There is no rename command. A couple of notes about RM. We saw RM already a couple of times. If you RM something, it's gone forever. There is no recycling bin for RM. Also, if you remove something accidentally because of a typo, it will be gone. There are systems that ask you if you really want to remove, for example, hidden files or write-protected files, but normally it's just gone without asking. Because if you use the command line, it's assumed you're careful and you know what you're doing. Making and removing directories works with mkdir, respectively rmdir. There's really not much about to say. Not really much to say about it. Type in a folder name, it will create the folder, as you can see on the screen. rmdir is a little bit special for that it doesn't remove directories with file content. It will refuse to remove directories that have something in them. You either need to delete all the contents first with rm, or you use rm tag r to remove everything that's below and including the specified folder. This means it removes recursively. But this is very, very dangerous. If you can ruin your system if you root and go to your directory root and just type rm star tag r. And your system will actually delete itself while it's running. That's how powerful this is. And it, as I said, it will be gone forever, irreversibly. So now we're about at 45 minutes. Do you want to take a break? No break? Okay, then we'll do a little demo. If I can bring it up. Yes, that works. So I showed you a lot of commands now, and I will just show them in a different environment with a little bit maybe more memorable context. We will have a look where we are right now. So our demo directory, we're in Middle Earth, and of course there are a lot of known characters around. Oh, there's actually a typo with those dwarfs. That doesn't look right. We can move those dwarfs. Come on. Using the competition here with tab. And then I type the new name. Oh, typo corrected. So let's have a look at those dwarfs. Oh, there are quite a bunch of dwarfs. But this list is not accurate. Thorin, Killian, Philly, they died. They were killed, as you all know. So let's correct this list. We change the directory first to dwarfs. They're all our dwarfs. Then we remove Thorin. Gone he is. And now we are lazy people. We can use globbing to remove Philly and Killy. Oh, that's an accurate list. Then, whoopsie, no, that's not what I wanted, but we can get... Tilde will always refer to your home directory, so we can make this very short. So we're back in our working directory. That's basically what we just discussed, very briefly used. We will work a little bit with this later as we discuss executables. but that's for now it. Yes. We talked about commands a lot, but how does the system know where is the executable actually stored? We previously saw this tree of directories, and there's usually a whole bunch of options configured where the system goes and looks for a command that matches what you entered as a name. Those are usually stored in USR, as mentioned. There is a little bit of a distinction between local apps that you maybe build yourself and want to use on the system for everyone, or maybe downloaded source code and compile it yourself. Those things go into USR local. USR bin is again a directory for command line applications and other normal applications. Bin we already mentioned. USR bin X11 usually contains graphical applications, and some systems come with a user game directory, but I think that's more or less an OpenSUSE specific thing. How do you run commands that are not in this file, in these locations? You need root access to bring applications to these locations, but sometimes you just want to run a small bash script you wrote yourself or got from a friend, and if you just type your command, the system will assume it's a system command, and if you specify a path before your executable, you will be actually able to execute this hello world. If you just type hello world, it will tell you, I don't know what hello world is. But if you type a / hello world, it will actually print what's, or do what hello world does. Hello world in this case just says hi. This also works if you specify an absolute path directly down from the root. That's sometimes a little bit long to type in, but as mentioned, it also works with the / or relative to a parent directory //. Configuration, we already saw the etc directory. Of course, there is also user-specific configuration. The user-specific configuration is stored in your user directory. What a surprise. But it's stored in hidden files. So all those .files, they usually contain configuration information in this case. There's a whole bunch of files we don't need to talk about, but those two here, the bash history and the bash RC, those work with your command interpreter. The bash RC contains instructions that are executed every time when you start a terminal emulator. You can set your font, your background, a whole bunch of stuff. You can also find more information in this about this with man bash RC. Then the bash history. If you ever typed something you don't want the system to remember, for example, you accidentally typed your password and you don't want everybody to see your password in the command history, just remove this bash history file and it's gone, all fixed. And the config directory, sometimes you will need to edit options that are maybe not accessible by a GUI. This is an example for XFCE. You just move into this .config directory, and then there you will see configuration for Thunar, for example. That's the file manager, or general XFCE configuration. This is a listing of the etc directory. There is a lot of stuff in there. It's here you can configure every single behavior of your system. But you need root access to do this, since this applies to every user on the system and a lot of the services and programs that are run to facilitate your computer usage. On the other hand, this here, this is local to you, that's only your stuff. There are a couple of notable configuration directories in etc. The cron directory holds repetitive jobs that are scheduled. Fonts holds the fonts that your computer uses. Hostname is used to configure the name of your system. If you want to give it a new fancy name, you can do that there. And systemd holds stuff that controls the whole service infrastructure of your system. So we already mentioned the infamous super user. Who is the super user? The super user is the administrative account of your system. It's basically God local to your system. It can view every file, it can change any configuration. Very in contrast to yourself, you only have access to stuff inside your own home directory. You can only change configuration that is in your home directory. You can see, but you can't access files of other users. Sometimes you even can't see files of other users. You can't change system-wide behavior. For example, you can't change, say, the time server where your system gets its system time from. That's something that's reserved for the root user. As we saw at the very beginning, root has its own home directory. It can really access everything. Usually you also get a little disclaimer that you should respect the privacy of other users on the system when you're accessing their files. Because you can see everything. There is no privacy from root. Root also is used to configure your system, as mentioned. It's used to install software, start and stop processes and services. If you want to become root, you must use this sudo command. The sudo command is just used to run individual commands as with elevated privileges as a super user. But if you want to do multiple commands or even a elongated session, you can use sudo and su. This su stands for substitute user. And if you don't give it an argument, it just switches to the root account. You have to type in your password and then your root. You can also log in as another user. For example, if Sandro and I share a computer and I want to use his stuff, if the system is configured in a certain way, I can become Sandro and work as Sandro. To get out of this changed user environment, you just type exit into the terminal. I promise you we will have a short look at software installation and removal and all that stuff. So we need to do a little bit of clarification, a little bit of terminology soup. The package manager, you maybe already heard about it in the first course. It's basically a middleware between the software that's installed on your system and the system or the software that is provided by your distribution. And a package manager obviously works with packages. So what's a package? A package is a bundle of software and configuration files and data that can be installed as a unit. So, for example, if you want to install LibreOffice because you want to write documents, you need to install the LibreOffice package. Of course, the LibreOffice package is divided in many, many different packages that are dependent on each other. You can't install the writer application without the LibreOffice core package, because the LibreOffice writer depends on the core infrastructure of LibreOffice. What the package manager now does is it looks up all those relationships and works out what needs to be installed, what needs to be downloaded, what's already there, and does it conveniently for you just with one command. Of course, also updates are distributed over this. Therefore, the package manager maintains a local list of what software is available. You can update this list with a command, and then basically the whole shopping cart of software is indexed, and you get a list of software that you can install. So now, how do you operate this beast? It's one of the favorite features of mine of a Linux system, because this thing allows to access your software securely without anyone tampering with it. It takes care of your updates, and it's all from one source. Obviously, you need a way to get an idea what software is available. You use the refresh command in zypper. This example is with OpenSUSE, but all the package managers, they work sort of the same. Here it's refresh with zypper. With a Red Hat system, with DNF or YUM, you use check update. We will see a list later for Debian package manager. Then with zypper update, you can update all your packages at once. It will just go through all your installed applications and will get you the newest and shiniest stuff that's available, or that's available for your distribution, rather. Next example is oh yes. Yeah, we go through a little example what happens if you type refresh. You see here it goes through all the repositories and looks at them and just downloads basically a new shopping list. Then with up or update, you tell the system to actually do the changes, the updates. In this case, we're safe. We have all the updates installed. Nothing is done. If you want to find software that's available, you kind of have an idea what the package could be called. You can use search commands. In this case, we search for Chromium, the free and open source version of Chrome. And then all the packages are listed that have Chromium in the name, and we just type sudo zypper Chromium, install Chromium, and the package manager figures out what packages are needed. Chromium depends on those two packages. It will tell you how much data will be used to download it and how much disk space it will occupy. Then it asks you nicely if you really want to do this. And there you go. It does everything for you, and after the command exits, you have Chromium installed. And maybe you're not very satisfied with Chromium and you prefer Firefox like I do. You just zypper remove Chromium, and everything that was associated with your Chromium installation is gone. That's basically the same process in reverse. It will tell you which packages will be removed, how much disk space will be freed by this, and it asks you again if you want to do this. These are the commands. Yes, please?
Question, where does it actually search for the software, and where does it install software from?
That's dependent.
For a camera.
Okay. she asked where is software installed from and where does it search for software. That's actually distribution specific. Each distribution maintains its own package repository. This is a really large server where all these packages are stored, and these servers also provide these lists. And if you do a search command, it first looks at your database that's stored locally and looks at how long ago was this updated. If it was 2 weeks ago, it first pulls the newest information from the repository and then searches this list. Or if it's new enough, maybe 2 hours old, it just searches locally. And if you then decide to install something, it will download the packages from the repository, and the repositories are usually hosted by the distribution and maybe the foundation that's associated with it. And there are also is the option to do your own repository by you at home, or for example the ETH has a lot of mirrors for popular distributions. Is that clear so far?
Yes, but how do we then install software outside those repositories?
How do we install software outside the repositories? That's actually a good question. There are a lot of packages available for download, just like you download an exe. You can go to, for example, the TeamViewer site and download their package. If they have packaged the TeamViewer software for RPM, that's one package format. There is another package format called DEP. It's basically different recipes how to build packages. And you can download it and install it on your system. There are also different distribution mechanisms that are more distribution independent, like Flatpak or Snaps. Or you can just get the source code from GitHub or SourceForge or wherever and run it through your compiler and run the binary. So there is really a huge selection of methods available, yes?
PPAs.
Oh, yes. Good that you say something about it. Ubuntu has this system of PPAs. Maybe you can say something about this?
Test. Okay, I think a PPA is best explained as a personal repository. This is basically a repository people can push to without being members of the actual official Ubuntu development crew. So basically you can set up your own channel that people can then subscribe to. And the PPA, you copy paste it into your software manager's list. And as a result, the software manager will consider it part of your repositories. So once you have added your PPA, you get your software directly from the developers, which is nice. But also you have to trust the developers, of course. Just like when you download something just from TeamViewer, that's like you have to trust TeamViewer as well. The other thing is that in contrast to just downloading a package from online with a PPA, it becomes actual part of your package manager, meaning that it will automatically install updates as soon as they are available. And once you have added it, you have absolutely no difference between an official package and the personal package repository, because you just use it together with all the other software. Package manager abstracts that away.
Okay, thank you. Any additional questions about software installation? Okay, then we go on with dealing with storage devices. We really only going to talk about one command, but one very useful command. It's the mount command. As I told you before, all storage devices are found in the dev directory, and they are usually labeled something like SDB or SDC. It actually goes up until ZZ, we found out recently. And then the partition on your storage device is designated by the number. And you can mount those file systems into a location in your directory structure. This is necessary because Linux has this one coherent structure of one tree, and you actually can also mount one file system into multiple different locations if you do it the right way. So it's more or less just like a hose or something. You just plug it in, and then if you look inside this folder, you see what's on the disk here. If you plug in another disk, you can see through the same folder. This here is called media. You can see the contents of another part of your disk. This is automated in the GUI. That's also the way how USB devices show up. As an example, you just click it, it will be mounted, you will have access to it, and if you want to unmount it, and this is especially important on the Linux, always unmount your devices, because Linux works with caches to accelerate your write operations, and will do them when it's convenient for the system. And if you have data residing in those caches and just yank the device out, you will end up with corrupted data. And if you use this unmount command, it will actually make sure that everything is written to disk. How does mounting actually work? You need to be super user to do this, so we will use the sudo command, and then we type mount, and we specify the device that we want to mount, and then we say where it has to go, and is there actually an example? No. And if you now do an ls on this my USB, you will see what's inside the USB. And as I said, before you unmount, you can do a sync that tells the file system to write everything to the disk that's currently in the cache. The mount command does this automatically, but if you wrote large files to disk, say 2 gigabytes, it's usually better to do a sync before you unmount, because you can see when the sync command has terminated. You can unmount with the umount command. It's basically an alias that is a simplification to the actual mount command that reverses the mounting. You can also type mount to just display what stuff is mounted where. I'll show that real quick. If you just type mount, you get this list, and if you have mounted something and you want to get rid of it, but you don't know where it went, you can look at this list, or other way around, if you want to find out what's the device called that is mounted on a certain mount point, you also can refer to this list. In the context of storage devices, I want to also say something about managing your free disk space. The df command lists all your connected devices. We see here again the tag H option that makes the whole thing a little bit more readable. You can see basic information about devices that are mounted, how big they are, how much space is used, how much is still available, percent of usage, and where it is mounted. And this is also another option to find out where stuff is mounted. And then just a quick little tip. If you run out of space, it's often a good idea to clean your package cache, because as we talked about before, a lot of information is saved about your packages, or even packages are cached locally on the disk, so you don't have to fetch them from the internet every time. And this can amount to quite a lot of data, and there are maintenance commands available in every package manager. In Zypper it's clean, in DNF it's clean all, in Aptitude it's also clean all. Then we will talk again a little bit about executables. We already had a little bit about that, but here we are going to talk about scripting and how you can actually write small programs. Scripting languages are languages that are not compiled into binaries, so you can edit them and run them just without much tooling. Python is such a language on Linux, but the most prominent one on Linux is the Bash. It's a little bit brave to call Bash a language. It's a file of instructions that follow on each other. It's like, you know, maybe from Windows, like a bat file. There are two ways to start or invoke such a script you wrote or you received from someone else. You can either specify the interpreter like Bash or the shell or Python, and then you type in the name of the file and it will execute whatever commands are in those files. It's very recommendable to check first what's inside those files, because sometimes there's stuff in there you really don't want to execute. We already talked about this. You don't want to remove stuff, for example. And if you're sure you want to execute this, just type in this and away you go. There's also a little bit more convenient ways to do this. You can start your script with a so-called shebang. That's a pound sign followed by a bang, and then a path to an interpreter. Usually this reads something like /bin/sh or /bin/python, and then you can omit this interpreter command. Shall we do the demo now? Yes, we do the demo now. As I told you before, we will again work a little bit with our Middle-earth universe here. As you see, I have Gandalf here, and Gandalf, he's a smart guy. He can do stuff. So let's see what Gandalf actually does. Gandalf at the moment doesn't really do much. He just says you shall not pass. So if I type bash and then remember you have to specify your local path, it says you shall not pass. Okay. Now, of course, you want to do actually useful stuff. So you can, on the fly, edit this file and tell it to do other stuff. For example, Gandalf is quite good about with defeating Balrogs. So we tell him to get rid of this Balrog. And if he's done, he will say, "Run, you fools." This, by the way, is Vim, just to give you a quick impression. And now we run Gandalf again, and the Balrog is gone. As you saw, without compiling, without any additional tools, really, really useful, really, really powerful to to automate stuff, to get a little bit of experience. Those bash scripts, they are used all over the place in Linux to make configuration files automatically. You can use them for DevOps and automatic compilation of stuff. Actually, there are in a lot of programs there are directories or hooks where you can put bash scripts, and if you know a little bit of bash, you can, for example, configure if you're a DevOps guy, your Jenkins installation to do custom stuff, just because you can do bash. There will be a bash scripting course next week. The dates will be announced at the end of the presentation. We just talked about this. If you want to execute something, you usually need to set the executable bit. Files are normally not executable in Linux. This is a safety precaution, so you don't just download something and it gets executed automatically, and or you run it by accident, for example. This is done with the chmod command. You have to apply it to a file if you want to execute it. This is an example with a other bash script. The a plus x tells the system to make it executable for all users, and then you can run it. This is a little bit a more advanced example with if and else statements. We want to know if I actually writing my thesis, if I'm doing my work, and for example, my teacher could run this shell script to observe me if I'm really doing stuff. And then, if this is the case, if this file is found, then he gets Simon started his thesis, so I'm working. If the file is not existing, this is printed, no thesis detected, and this command, this will just repeat whatever you type in, so this is going to produce a very long and very annoying output of start your thesis. It's a great way to get you working. Of course, there are loops, all kinds of loops available, for loops, while loops, do while loops. You will see this all in the bash scripting course. I hope you all registered for the bash scripting course. It's a lot of fun. A little bit closing thoughts on automation. Scripts are also a little bit dangerous, as I told you. Don't just run everything you get from anywhere. They're very powerful, as we saw. You can run them when you start your system, when you log in, when you log out. I, for example, use it to connect to my NAS automatically. When I log in, it automatically connects to my NAS. You can, for example, if you're a home engineer, you can connect a, say, temperature sensor on your laptop to a script that tells a Raspberry Pi that's connected to a motor to open your window because your laptop needs fresh air. Everything is possible. Then a small, let's say, closing thoughts on the whole topic. Commands are very universal. Basically, everything that's installed can be run as a command. Most GUI applications also have a command line backend where the GUI is basically just a nice, shiny wrapper around the little bit more scary command line side. There are also system commands that are very useful. Shutdown and reboot You can manage all sorts of operational properties. You can turn on and turn off Wi-Fi. Really, everything. I know people that only run command line, no GUI. Very brave people, but it's doable. Scripts make it easy to automate stuff and reuse commands, and yeah, from here on you can really build up your knowledge and also your power over your computer. Oops. So now, as I advertised before, the Power of Linux course. This is more of this, but really advanced stuff. I really recommend it. Go and have a look at it. This will be tomorrow. Then on Friday we will have a general Q&A. If you still have lingering questions, for example from the install day, or if you hit a certain problem, if you're looking for specific software, just show up in the UZK call in the Lichthof on Friday between 5 o'clock and 7 o'clock, and we will hopefully answer all your questions. Then, as advertised, the Bash workshops, those are next week on the 3rd and 4th of April. Oh, there's a typo. Also same time as today, but mind it's in D5.2. Then a very topical lecture is private email with GBG. Someone will be teaching you about how to encrypt email and how you can establish trust between people you know. You also will have a look at how to encrypt files and decrypt files. Really fun stuff, really useful. And the last lecture will be the most advanced one, distributing scientific, free and open source software. This will be a talk how to package and distribute your own software, specifically scientific software for Linux. This will be on the 11th of April, same time, other location, this time. University of Zurich, again in Call, but in G217. We always are open for new members. You're welcome to join us if you also want to have a talk or help with the install days, or just generally want to chat about Linux. You're always welcome. Also, if you're not a member too, at our Stammtisch, this is every 2 weeks during the semester. You can find the schedule on our website. Generally, check out our website. We have the presentations available there, the video recording of this session, and all the sessions will be available there. There is a lot of knowledge too. And yeah, the last thing that I have to say is thank you for coming. And stay engaged, stay interested, stay curious. Have a nice evening.
All right. Thanks everyone for coming. Please fill out the sheets. It would help us very much. Thanks. Also, if you want to still talk to us, we're still here for about another 10 minutes or so.